Or in describing the shape of the data distribution. One relevant measure to talk about is the measure of asymmetry. Okay, the measure of asymmetry, which talks about whether the curve is skewed or it is symmetric. Okay, and one statistic or one quantity which is used to describe the distribution of the data is the measure of skewness. The measure of skewness can be estimated using the Pearson's coefficient of skewness, first coefficient of skewness, which is defined as the mean minus the mode of the data over the standard deviation. And then the Pearson's second coefficient of skewness is defined as 3 times of the mean minus the median over the standard deviation. Okay, so this we use in the case when we don't have the mode of the data, or when we are not given the mode of the data. Okay, very well. So let's see how to calculate this as well. So this time you have to be quick with the calculation of the standard deviation. Okay, you have to be a bit quick with it, and please get your calculators with you. Don't sit there idle and just waste the time. Okay, good. So let's take an example and then try to find the Pearson's coefficient of skewness for the data. Okay, so we're taking this data here. We attempted this data earlier. Okay, I'm going to add okay, fine. So let's try to do this together in order to find a mean. I don't want us the standard deviation. I don't want us to delay much. So 4.8 minus the mean, which is 4.994. Okay, 9429. What do we get? That should give us what? Negative what? Negative
0.142.
Hello, class.
Yeah, sir.
Yes.
Negative 0.1.
1429. 21. Okay.
Yes, please.
Okay. Then the next one, 5.4 minus 4.9.
It's 29. Yeah.
Okay. The next one, 5.4 minus the mean.
0.45. 0.457.
What do we get?
Zero point 457.
0.4571.
0.4571. Good. Then the next one. Okay, 202 class. Let's do this calculation to speed up a bit. So what do you get for the next calculation?
Negative 1.0429.
Negative 1.0429.
1.0429.
429. Yes, next value.
Yes.
Next value.
Negative 0.2429.
0.2429.
2429. The next
1.4571.
1.4571. 1.4579.
Okay, whilst we are doing the calculation, somebody should be doing the squares for us. When we are done, we'll be squaring them, so somebody should do it for us. Then the next one.
1.1571.
1.15 to
71.
okay, 71. Okay, thank you.
Yes.
Okay, so let's square them.
0.020.
0.
The first one.
Yeah, 0.02.
Okay. Okay, next one. 0.1 what?
0.20.
0.20. 20 what?
0. 0.20.
0.209.
9, okay.
Or
Next one.
209. So it will be 0.21.
No, don't approximate. Approximate to 3 decimal place.
Okay, so 0.209. Say.
Yeah, okay. Next one.
The next one is 1.0876.
1.088. Okay, next one.
76.
0876. So that's 088 to 3 decimal place. Next one.
The next one will be
0.059.
0.59.
059. Okay.
Yeah.
Next one.
The next one is 2.123.
2.123.
Yes.
Next one.
1.817.
1.817. Okay. Then we sum them up. Okay. We need summation of x minus mu squared. So you sum the squares up. So sum everything here. By the way, I'm taking note of those giving me the responses. I have Yvonne, I have Wilson, I have Charles. Okay. I have Dennis. Bam, I'm not hearing from you. Edna, I'm not hearing from you.
So the summation of square.
Yes.
5.2629.
5.2629.
29.
9. Okay. Are you sure? Are you sure of your answer?
Yes, sir.
We're working in 3 decimal.
Yes, sir. If it is not correct, then the last value is not correct, sir.
Yeah, I said we're working in 3 decimal place. So how come you're getting 4 decimals?
So that's 5.2. If then 3, the last one will be 3 instead of the 9 at the end. So make it 3, sir.
Okay.
Yes, sir. Thank you.
Yeah. So let's find the standard deviation. That will be over a number of observation is 7. So divided by 7. Okay, that is the variance. So to get a standard deviation, we'll find the square root of that quantity. So that will be square root of 5.263 over 7. Okay, so let's find the square root of the quantity.
That would be 0.867.
0.867.
867.
Okay, very good. Very good. Nice contribution. So the next thing to do will be, now that we have the standard deviation, okay, to get the coefficient of skewness, like you saw earlier, one of the formulas has the mode and the other has the median. Okay, so either we're going to use the mode, that is if it is known, mode is the highest occurring frequency, like you saw from lecture 2, or the median, which is the middle observation from lecture 2. Okay, and like we are seeing in this data set, okay, we do not have a mode. We don't have any highest, they are all occurring once. Okay, each observation is occurring once, which means we have to fall on the middle observation. And to do that, you need to rearrange the data first in ascending order, okay, like we saw from the first class, so that will be 3.5. Next observation will be what? 3.9. Next observation will be
4.7.
4.7.
4.7.
Yeah.
4.8.
4.8.
5.4.
5.4.
5.2.
No, 5.2.
6.1.
5.2.
Yeah, 5.2. And then what? 6.1.
6.1.
6.1.
6.4.
And then 6.4.
And 6.4.
Very good. So we also know the formula for finding the median position, but I'm going to use a shortcut formula, okay? Just for the sake of this class. So we have 7 observation, which means that the middle number, okay, will be our median, which will be 4.8, okay? Good. So if you want, Pearson,
Yeah.
yes.
In the values given, there is no 5.2.
This is 5.2 here.
I'm looking at the one in the distribution table.
In the table.
Yes.
Then we've left it out.
We use 5.4, not so.
Yes, sir.
Okay,
Yes.
no problem. Whether 5.4 or 5.2. Okay. It will affect them,
Sure.
but let's take it to be, yeah, either 5.4 or not. But the median is still the middle number here, which is the 4 value.
Yes, sir.
So that will be 4.8, right? So if we are calculating our
Yes,
PCS,
sir.
okay, PCS2 is going to be 3 times of your mean, which is 4 0.943. Okay, minus, we have your 4.8. 4.8 over our standard deviation, which is going to be 0.867. Okay, so let's find that. I think the numerator will be 3 times 0.143. 0.143, okay, over 0.0867. 0.867. Okay, so calculate that for me, give me the final answer. What do you get finally? What are we getting?
Sir,
0.495.
0.495.
Okay,
5.
very good. So this will give us just a minute.
Skewed to the right.
So 0.495. Okay, very well.
Yes, sir.
So with this understanding, I'm going to show you how to interpret the value. Now, this is how you interpret it. If the value of the skewness, okay, is less than 0.5, that's negative 0.5 to 0.5. In other words, if you have a value like negative 0.2, okay, negative 0.2 is greater than negative 0.5, but less than 0.5. So the skewness lies within this interval, okay? If it lies within this interval, then we say that the shape of the data, the distribution of the data is approximately symmetric or approximately normal. So when we plot the distribution, it will look approximately what? Normal, okay? But if the value exceeds these values, assuming we have negative 0.6, negative 0.6 makes it skewed, negatively skewed. And then 0.6 above will also make it what? Positively skewed, okay? Will make it positively skewed. Now the question is, what do we mean by the negative skew and the positive skewness, okay? Good. Now, when you look at the formula carefully, you realize that if this formula here, because the field is okay. So before I move on to the interpretation of the graphs as well, another thing we have to know as engineers is when it comes to practice, okay, the skewness of the data, even though this is the theoretical value, you interpret between negative 0.5 to positive 0.5. Because skewness is affected by the number of observation, okay? The skewness or the normality of the data is affected by the number of observations, okay? We tend to interpret the measure of skewness relative to the standard error of the skewness. Okay, indirectly, what engineers usually do is we interpret the skewness within 3 standard deviations of the standard error of the skewness. I think you understand that better when we get to inferential statistics. Okay, but like I said, at this level, what you need to do when it comes to interpretation is to use a scale from negative 0.5 to 0.5 for interpretation. But as we go deeper and get into more practical examples, we will be seeing more advanced interpretation of the value for the skewness. Now let's go on to the graphs and understand what we mean by positive skew, negative skew, and then symmetric graph, and then we wrap up for the class. First factor, okay, and the median or the mode is a second quantity. If the mode is bigger than, if the mode, okay, is greater than the mean, then we are going to have a negative skewness, okay? If the mode is greater than the mean, we will have negative skewness. The same way, if the median is greater than the mean, we will have what? Negative skewness. Otherwise, or vice versa, it will be a positive skew, okay? So let's look at the shape of the distribution, which we have seen before, but this time we want to analyze it carefully. So like we said, in the case of where you have your mode, okay, usually your data will start from you. For the sake of this lecture, let me put this as the least value 0, okay? And then the measures of central tendency, this is the mean. We have the mean here. Okay, the mean is X bar. The median is the middle value here. And then we have the modal value. It's always the highest occurring frequency. So in the case where the mode, like we said, the mode is bigger than the mean, the formula says mean minus mode. Okay, mean minus mode over standard deviation, over the standard deviation, ST. Okay, so if your mode exceeds the mean, then we'll get a negative value. Okay, if the mode exceeds the mean. And clearly here we can see that the mode per the scale on the x-axis, the mode is greater than what? The mode is greater than the mean. Okay, so a left skewed data is also referred to as a negatively skewed distribution. Okay, left skewed means, the word skewness means shunning. Skew means to shun. So it appears the data is shunning the left side in favor of the right. So a left skewed data is also what? Negatively skewed distribution. Okay, the same way when we go to a positive skewed distribution, this is how it will look like. No, I think the interpretation for positive skewed and symmetric will be very obvious, okay, to you. So what I recommend is just go to YouTube and watch that section of the notes, okay? Or okay. Yeah, I don't think that should be very difficult to understand. So let me take 1 or 2 questions from the class, and any comment relating to the course before I hang up for today's class. If there are any questions, any issues, you can bring it up before we wrap up today's class. Yes, Wilson. next week and enjoy your weekend too. Okay.
You too, sir. Thank you.
Yeah.
Yes, sir. You too.
Thank you.
When I locate any party anywhere, I'll invite all of you to join the party. Yeah, bye bye.
Thank you. Sir.
So we'll gladly come. Bye.